Ravi sir, shall we start the next session?
Yeah, please, Professor.
Yes, sir. We welcome you back, all of you. So we'll be having the next session by Ravi sir.
This one is about
Screen share.
yeah, Ravi. Yes, sir. Yes.
Yeah. The next session is on enhancement of functionalities by surface testing of additively manufactured components by Ravi sir. So, sir, we look forward for your session. Thank you.
Thank you. I think you need to unshare.
Yes, sir. Yeah. Yes, sir. It's sunshine.
Can you able to see my screen?
Yes, sir. Yes, sir.
Yeah. So I'm going to talk on my core area of expertise. Previously, we used to use that particular process for as a component ready. Basically, micro machining is our prerequisite for nano manufacturing. So we mostly work into the nano manufacturing aspects. Okay. So whenever you see about additive manufacturing components, this is the basic problem of when you 3D print by powder bed fusion or wire based WAM or TWAM or DED or DMD, whatever you mean to say. So these are all, whether it is electron beam melting or laser beam melting or anything, the surface is, the roughness is very, very high. So mere 3D printing is not a complete solution actually. Okay. So you need to do the post finishing of these particular things. That is where we, our core expertise. For example, if you take any part of 3D printed component, whether it is an internal component, whether it is the external component or something, this is the surface it look like. Okay, macroscopically and microscopically. You need to do remove of these balls, which is called a deballing operation. In the roughness is there and waviness is there because you see the peaks. So roughness is all about low amplitude, high frequency signals, and waviness is all about low frequency and high amplitude things. Okay, lustrous is required, shining, microstructure. Some people they say spherical is required. Some people they say granular. Some people say nodular structures, flatness, maximum peak to minimum valley, and some people ask also about compressor. So customer requirements will be different. So how do you achieve all these things? Okay. So what we try to work is how do we convert a 3D printed component into a final product. So now here the thing is the people talks about when you want to use 3D printing, you will use for complex surfaces only. If it is not a complex surface, you don't use because it is uneconomical for you. So when you are making a complex component, so surface will vary the radius of curvature from point to point or most of the cases. So in that circumstance, how do you overcome is a big problem. Okay, so that is all about. So there are two major verticals that we have at IIT Tirupati, and I'm sure that we are one of the people where we have this many processes at in India basically. Okay, in India or abroad, wherever you take. So we ourselves is happy to say that we have many processes ranging from chemical finishing to electrochemical finishing to electrochemical plasma finishing to dry electrochemical finishing. So these are the varieties of process that we have, so that you can see as professor pointed out that we need to close in half an hour time so that I can take up the questionnaires and so on. So Chemical finishing, we develop the chemicals as per the requirement of the customers, definitely. So we need to understand metallochemistry of the process. Okay, so that is a primary requirement before and after. So that no shininess and other things will come. So most importantly, we use this particular chemical polishing for lattice structures finishing and so on. Okay. Second, we use electrochemical polishing that you can see here. Okay, so this is how anodic dissolution takes place, so that the roughness will takes place. So roughness will reduce. You can see here initial as-built surface using laser powder bed fusion at intermediate and fine finishing. So it not only gives the finishing process, but also it will give you very good shining. Okay, so you can see here the surface roughness is 9.73 microns to final finishing 0.6 2 microns. That is the capability of this machine, and predominantly most of the industries uses this particular process because this process is economic. So this is electrochemical plasma polishing. Basically, you can see here, this is nothing but your EDM plus ECM type of work. So where you can see here the as given the component, it is as built, later it is rusted, because when we get the customer component to prove, you see how the finishing takes place. For simple geometries, you see medium complex geometry, like these are the geometries that we are getting. So this is a part of tire molds basically. So tires require some geometries, no, for gripping and other things. This is a part of a tire. So some company tire manufacturing molds basically. So these are the portfolios of electrochemical and chemical and other things. Dry electrochemical polishing, I am not talking because some of our papers are under consideration and so on. Okay, so these are the some of the applications you can see here. Finishing, after that how the electrochemical, not only finishing happens, it also give lustrous. Lustrous is nothing but your beauty basically, or chamakta hai na. So I mean to say shining and other things. You can see here bone plates. At the same time, this you can do anodization and so on. Okay, so if you clearly see the image that is we are taking, it is clearly reflected. The person who is taking the image, his camera, his fingers, everything is clearly visible. So now we also work into the area of abrasive fluids, and yeah, we do have drag finishing, vibratory bowl finishing. Today also we have a discussion with one of the company about this type of finishing that is required, and this is a setup that we have at IIT Tirupati, drag finishing applications. And this we don't have definitely, but this is the one thing that we would like to have in future. So this is called belt grinding operation, which is completely controlled by the robot and other things. As I said, a big challenge is whenever you want to do for external surfaces, it is slightly easy compared to this one. For example, whenever you want to do for internal surfaces, it is very, very difficult. Okay, so these paths are very complex, and nowadays 3D printing gives the flexibility to design as per their requirements basically. For example, if you see the image 1a, I mean to say lot of channels are there. At the same time, cross section is varying. At the same time, their geometries are completely complex. One is inlet is there, one is outlet is there. How do you finish these things is a big question. Some of the requirements comes from some of the abroad companies. As I said, I'm very fortunate that this is one of the project worth of almost 6.8 crores. So which is a combination of Indian technology as well as German technology, where we try to do the polishing of this particular thing. Okay, so this gives us, so visiting faculty and visiting scientists to Germany, Fraunhofer Institute for ILT, Institute for Laser Technology, and so on. Okay, so what I mean to say is that if you can see the complexity of the channels inside, these channels need to be polished. How do you polish? So one of the technology, for example, simple, if we want to polish this, if I want to put a diamond particles in a water, so what will happen? Because of the density difference, the particles will sediment and finishing will not be the uniform. So we develop semi-solid cutting tools, so on. So at the same time, we develop the extrude hole setups under the sun. So this is an overview of the setup that we have seen here. Second, this is developed as a at IIT Kanpur, then IIT Gauhati. As I said, no, I worked in IIT Gauhati for 7 years. Now my 7th year going on at IIT Tirupati. And this particular work is started at IIT Kanpur basically. So it is a combination of IIT Tirupati, IIT Gauhati, and IIT Kanpur. I'm very thankful to DST basically. DST under the TSDP, we got nearly 1 crore for developing this particular process. This particular process has complete setup, then the fixturing, then the medium. Most important is the medium that we develop. It ranges from high viscous to the low viscous and so on. Okay, so how the additive manufactured component is going to finish, you can see here. Just watch the video. So the semi-solids can flow to the nook and corners of the complex surface to finish. Okay, so that's how this will do. So at the same time, the advantage is you can design your fixturing. Fixturing is to hold the component. In this scale, for example, you have a small impeller is there. You need to hold firmly and you need to divert the fluid accordingly so that now you can do the finishing from 1.75 microns to 0.4 microns and so on. So how this particular technology works is predominantly this particular slide looks very easy when you are listening, but it took almost all 3 years of my PhD. Okay, this particular slide. So for example, I have a viscoelastic fluid. You can see here P is there. So you have two-phase fluid here. One is a continuous phase, which is ash color. Another one is you have a blue color abrasive particles and green color abrasive particles. The difference is blue color as abrasive particles are taking part in the finishing process and green color is not taking. That's why active particles and passive particles. But however, I am not concentrating on abrasive particle. I am concentrating on a continuous phase. When I am applying a shear force on it, viscous force try to move in this upright direction and elastic force move in the perpendicular direction. I mean to say, viscous, for example, if you take honey into the hand and try to push or throw, in the direction of your throw, it will go. Am I right? That is how it will be. Okay. So second is when I am whenever there is a radial force is when I am pushing in the direction. Assume that you have a pencil eraser. You are pressurizing. What will happen? It will deform in the radial direction. So because of that, what will happen is that so now it will move in the perpendicular direction. Okay, so that will you can anyhow you can evaluate by rheology and other things. So now you have an abrasive particle here. When I am pushing, axial force moving, viscous force move in this direction and radial force will move in this direction. If I can control viscous force and elastic force of that particular semi-solid medium, I can control the depth of penetration as well as movement of the abrasive particle in this direction. Because of that, what will happen? Whether you want to micro cutting, whether I want to sub nano cutting or nano cutting, all those things are shearing you can take place. So this is our medium. Commercial mediums are very expensive. Our medium, you can see the first one, how it is a time dependent fluid. At the same time, if you are pulling very fast, it breaks into pieces. When you are pulling very slowly, it is comes like a bubble gum. So our medium is non-hazardous, eco-friendly, and other things. So we are low priced. So those people who want to work, recently we are getting orders. We are start getting orders officially. So we are working with our institute how to go about it and so on. So we are very grateful that to the big organizations, multinational companies that they are working on it, and we have already given for the testing to some of the companies, and test reports are already achieved, and they have given us very good test reports also. So this is about the three varieties of medium commercially available. However, we have whatever your requirement, we can make as per your requirement. Okay. So then once you make, whenever person want it, what is the thing is, the best thing that people want is that how it is in line with commercial mediums and other things. So we have to calculate our calibration curves are need to be drawn with respect to. So this is the calibration curves that we are drawing with respect to other mediums. Then once this is done, the medium is done, then we have to see the efficiency of that. So the first and foremost that we have done is on the Markforged things, where the surface roughness is very high, and we have finished. And some of the things you cannot do because this is a 3D printing issues. So the surface finish is achieved. Later we have tested on laser powder bed fusion based SLM components, select laser melting components that you can see here. The surfaces are pretty polished. Okay, so that means, for example, if you see you have a component of 7.4 microns, we have achieved almost all 0.4. You can see here 7.4 to 0.5. I mean to say this, the best surface finish recorded by the commercial companies has been achieved. So indirectly, what I mean to say is that we need to transform this particular 3D printed component into this type of things. Okay, so that no, you can make. Once you make this thing, once you have wheat flour, you can make chapati, parota, dosa. So only thing is that as an engineer, first I want to demonstrate on the flat surfaces. Later I can do for any type of surfaces. Okay. So these are the some of the surfaces that you have seen, which are done by the commercial companies. And we also can do biomedical implants finishing and so on. Okay, so these are the art walls and which we work with respect to, I mean, say, tabular heads and other things which we work with respect to our collaborators and so on. Later, for example, if you see here, whenever you talk about drug eluting stent, I was telling you in the previous lecture that I'm going to talk in the next lecture. For example, whenever you try to do the laser micro machining here, what will happen? You have a surfaces like remelting surfaces here. So melting and evaporation is the principle, basically laser micro machining. In that circumstances, some of the things that you can see here is molten material will resolidify basically. That's why it is called recast layer. Okay, so you have seen the Gaussian beam distribution of the laser. This Gaussian beam distribution will be doing the machining at the center. However, it will not do at the edges. Because of that, what will happen? Some of the material melt but unable to evaporate. That material will experience the room temperature, because once the hole is drilled, the laser will move on to another place to drill. So the previous one is experiences the low room temperature and so on. So in that circumstances, how the surfaces, functional surfaces look like is this. So for example, it has to be developed for cardiovascular stent application. You can see here recasting how it is taking place, and recasting surfaces are very, very dangerous. And that's why we are very happy to say that this particular funding we have received from BIRAC, Biotechnology Initiation Grant, about 41 lakhs for gold standards development of this particular drug eluting stent applications. What is the thing here? You have three varieties of drugs. One is when there is a stent is there, you have defatting drug, antithrombotic drug. At the same time, you will have a blood thinner. Three drugs has to be eluted through this hole. When you need to elute, these surfaces will have multiple problems. First problem is it is very rough surface, so eluting rate or releasing rate will not be as per the requirement. Second, this recast layer, which is not part of the parent material, will come out. And the third and most important one is, if metallochemistry is designed as per the parent material, not designed based on these metal oxides or metal carbides that are formed. So these are the problems to overcome, and our medium can have thermal sensitivity. Today you have a large component, tomorrow you have a small component. So you can design the viscosity with respect to temperature, because our systems will have temperature controllers, so that you can design whatever the viscosity, and then you can do, not only it will work for lasers, it also work for micro EDM applications that you can see here. Micro holes are finished so that the drug eluting will happen perfectly. I cannot say 100% perfect or something, but better. And most important, it will not carry the recast layer and so on. So that is what the beauty about this particular project. I'm very grateful to the Indian government for choosing us for funding. Initial case, they were very, very, because when I approached them with this, normally BIRAC people will expect some chemistry, and they were asking some chemistry. They thought this is why I'm designing the drug basically. So later I explained this is what then. So there was a second review. I'm very fortunate that the people have identified this, and we have got the patent also, and we are happy about that one. Okay, so this particular technology can be adopted to the fuel injector nozzles. Anyhow, all people are moving towards EVs now. Definitely, some of the things. See, for example, if you don't do the polishing, this is where the fuel will be ejected, and a lot of particles will go, and your engine cylinder may damage. So you require not only finishing, but also you require radiusing and so on. So the deburring and radiusing and turbulent holes and so on. As I said, Rome is not built in a day. So this particular work has started in 1996 and 2005 to 6 and 2007 to 8 amendments. Currently, we are able to do at IIT Tirupati the commercial machine that you are seeing. Okay, so obviously, when I joined at IIT Kanpur as a research scholar, so I got this particular project because this project was a ARDB project. For ARDB project, some of the things limitations will be there. You cannot procure from abroad and so we developed our own commercial solutions for some of the defense applications and other applications also. This is the front view of this one, and you have a smart manufacturing. So don't think that the smart manufacturing is all about measurement the temperature or measurement in the forces or something. No, you need to design your HMI, human machine interface, and other things. So that no, and for that you need to have a control panel. And this is the project that we have collaborated with Delhi. Control panel and HMI was their work, and complete mission structure was our. So as I was telling you in the previous one, so I will explain about various processes that we have. Abrasive flow finishing process, that is the one. Laser micro manufacturing, which we have a heat axis is there. As I said, micro tools, DT100i that you can see here, I is there. So we have a track finishing setup, we have a 5-axis finishing setups, we have rheometers, we have Luminex Plus, where you have seen 3D bioprinting, the channels and other things. We have Brooker Contour, which is a 3D profilometer, and 3D EVO filament maker is there. We have ball milling for nanoparticles, microparticles. There we have a ceramic 3D printer. We have spray jet nozzles. We have CLX 350, which is a DMG Mori turning setup. CMX 600V, which is a DMG Mori milling. And we have EOS M290, and we have Artec say tribometer, and we have a sophisticated Agile Charmilis Viridium. The Viridium itself is almost all 80 lakhs. So this is about the facilities that we have, and these are the facilities which are coming to us, and we are open to summer interns for approximately 5 months or something, and we are open to postdocs and those people who want to do their BTech projects, MTech projects for 1 year. We support the MTech students, those people who are there who want to come and work. So that if they work, it is good for your institute or our institute. If you can publish, so we are happy to publish along with your supervisors who are from your institute, because their contribution also will be their technical contribution. So, and we are also ready to take up partial PhD works, so that our machines utilization will be there. As I'm speaking as an HOD of the department, so that no some revenue generation will takes place for our machines, so that our maintenance will be done and other things. So for everything you can discuss with us definitely. So we are more than happy if you can come through proper channel. And again, I'm iterating that those people who are interested, they can submit this one. Now I'm going to thank all the acknowledgements. Started my career at IIT Guwahati with 5 lakhs. Then Bayrak about 33 lakhs. DST, as I said, no 1 crore, nearly 1 crore. I got it for developing that machine. Then got the 75 lakhs from DRDO. And DIT, nowadays it is my team, Ministry of Electronics and Information Technology, about 60 crores on theranostics. And imprint about 3 plus 3 crores from for IIT along with IIT Kanpur and ISC Bangalore. These are the projects that we have completed. These are the projects on the edge of completion. So SCRB special call about 45, BIRAC about 41. As I said, not drug eluting stent 1. SCRB about 32 for internal. And as I said, Indo-German, we have a 6.8 crores funding for that one. And currently, just now, we received some of the projects from Respond, ISRO about 32, DST about 61 lakhs, and 56 lakhs small projects from IK, STARE. And TARE is one thing that private engineering college people, you can apply to IITs. Being a faculty, you can come in summer for 60 days, or throughout the year, you have to come for 90 days. Or, I don't know exactly rules. You have to go through the rules. You can apply and you can come here, so you get a funding, so you can execute the research work. ISRF is not for you. ISRF is for outsiders like Bangladesh, Sri Lanka. These people will come for us for almost 5 to 6 months here, and they will execute. So we are very grateful that IITE is the name, who came from Myanmar, and she stayed here. Our group, as I said, no, we have summer interns from foreign countries. We have PhD students from foreign countries and other things. And current small consultancy projects, we get cars from DRDO again, power grid projects, another thing. Apart from it, we are having 120 crores from TAH, which is a technology incubation hub at IIT Tirupati. I'm one of the vertical that is micro manufacturing and so on. With this is one side of the coin, and this is my team that works day and night. I am just a front face out of it. So with this, I'm very grateful to the organizers who have given the time and asked me to have more time for the discussion. So that's why I just shown you what is about a nano particular thing that we do for additive manufacturing. With this, I am open for the suggestions, comments, and queries. If you have anything, I'm ready to take up. Thank you. And this is my details, and I request to not share to the students or something. So if anybody want, they can approach definitely if you are from industry or. And I am happy to say that we are going to organize from March 3rd and 4th Indo-German program as a part of our Indo-German project. So those people who want to come, they can come and participate. If you want, I can share the brochure to the organizers. They can share. Thank you. Yeah, I'm done, Professor.
Yeah, Ravi. So I request participants, the platform is open for question answers. In ample time is there. So this is the opportunity. Try to make use of this opportunity. Yeah, any questions apart from technical, non-technical questions also, but pertinent questions that can be asked. So I'll remove the restriction before that. Yes. Mm, I think now you can use your unmute yourself and you can ask. Yeah. Participants. By the time they gather courage to ask any questions, I have few questions. Just in the first session itself. Yeah. Ravi. In the first session, discussed like some points were there regarding funding, research funding.
Can you able to see my screen?
Yeah, screen is visible. Yeah.
Yeah. So this is the program that we are conducting. Okay, so in the German Symposium on Advances in Additive Manufacturing. So those people who want to do, they can come actually. Okay, so now anyhow, we are getting lot of requests from the people. So can you reduce the? See, this is the cost that we have put registration details. At the time, we are thinking that sponsors will be very less because we thought now we have got some sponsors, so we are charging for students and research scholars almost all 1500, only half of the charge we are doing. Academic faculty also who are asking, we are reducing by 1000 or 1500 or something. Okay, but subjected to banquet basically. So there is a banquet for industry people. Banquet is, we are going to take them to a hotel. So that is the one. Otherwise, because a student says, okay, they are may not be that much interested in banquet. They are interested in reducing the price. So we are charging 1500 only for the students and academic. Now we are saying 4000, but anyhow, it can be it can be 3500 also. So people are who are interested, they can please come. And anyhow, we got the sponsors, so that's why. And we are going to release the speakers list tomorrow or day after tomorrow. We are working on it. And the focused area is powders manufacturing for additive manufacturing, feedstock, and then modeling and simulation, then AM for casting, dies and tools, defense and aerospace applications, biomedical applications, bioprinting, micro additive manufacturing, post additive manufacturing, and so on. So these are the areas that we are working. And anyhow, Tirupati, not only academic, we also have a lot of places to visit, like Tirupati, Tirumala, and lot of temples are there and other things. Those people who are interested, or I'm sharing this with I don't know whether I can uh, share here. So if I can share, I can share to you people. Thank you.
Yeah, Ravi, you can put in the chat box if any attachment is. Otherwise, you can send it to me. I will share it with the participants.
Yeah, I don't know whether I can put the attachment here so that they can load. I don't know.
Yeah, I think attachment is not there in the chat box. So you can share it to WhatsApp me, sir. I'll share it with the participants.
So I have only one number from institute, that Vinayak ji.
Yeah, myself.
Oh, your name is written something else here.
uh, actually, as a this thing host, I have logged in through Ganesh, my
Oh,
co
okay. Fine.
I'm Vinayak speaking. Yeah.
Okay,
Okay. Yeah, you can share it on my number and I'll pass it on to all the participants. We have our
yeah, so registration, you don't worry about registration. So we are flexible on the registration. Now we got some funding, so we are flexible. We are looking for many participants so that no. So if the participants comes, more sponsors comes. So we don't have any much problem regarding to host. Okay. So but you need to uh, at least, because we want to check the sincerity. I sent you, Professor Vinayak ji. And
I'll just forward it now itself. It's a WhatsApp because we have our FDP WhatsApp group.
yeah.
Everyone can get it. Just a second, sir. Yeah, 8.5 MB, no?
8.5.
Size is 8.5 MB.
Yeah, you can just forward that, sir. And just write them that the registration is not a, that can be, we can waive off 50% for students, because no, many of the students, because I also did PhD, no, our पिताजी 50 रुपए देता था, so ऐसा ही होता है.
Yes. So I have shared it in the group, and 50% waive
Yeah.
off.
So those people who registered already, we are giving them reimbursement of 50%. Those people already, there are many registrations who paid the full amount. So those people we are giving them option of reimbursement of 50%, or we are taking them to the banquet. Option we are giving to them.
Okay.
Yeah, banquet will cost us almost all 2000 plus. Okay, so because it is in a star hotel. So okay, so yeah, we'll come back to our regular discussion.
Yeah. So I have posted something in the FDP group.
Hmm.
So almost like 181 people are there in that registration.
Yeah, yeah,
So
you can post. It's useful to them. You can post to your some faculty and other more groups are there. Yeah. Okay.
there is one or two questions. Yeah, two questions in the chat box. Uh, we'll start with Rayappa Srinivasi.
They
Raviji,
can ask. No, they can ask why are there. You just ask the.
Rayappa ji,
Oh,
you can.
yes, yes, sir. Sir, good evening, sir.
Yeah, you can introduce and ask, Professor.
Yes, sir. Sir, I am Rayappa Mahale from Department of Automation and Robotics, JSPM's Rajarshi Shahu College of Engineering, Pune.
Hmm.
As you said, sir, there are summer internships as well as project uh,
Hmm.
facilities available in IIT Tirupati. I just wanted to ask you whether internships are and project work is related. It is available for mechatronics, robotics, and automation domain students, sir.
Yes.
Okay,
Yes.
sir.
Yes.
Yes, sir. Yes, sir. Okay, sir. Okay, sir. Sir, what is the procedure to send our students to your institute, sir? Is there any?
We don't entertain for 2 months.
Yes, sir. Yes, sir. Yes, sir.
We
Even
are going to.
they need internship of 2 months only, sir. Next semester, in the month of May, they have internship schedule, sir, for 2 months. So what is the procedure, sir?
No, that is what I'm saying. We don't entertain for 2 months.
Okay, okay.
We take only for long term because no 2 months में वो आके क्या करेगा कुछ ज्यादा नहीं हो पाएगा ना.
Okay, okay. Sir,
So
maximum duration is how much, sir?
normally nowadays in NEP, no, we have a semester program. No, they can come
Okay,
and work for a long term, so that no, it will be beneficial for both the people.
okay, okay, sir.
But anyhow, it is not that we are not going to entertain or something, but there is a see, we can send. We don't have any problem as such. But
Yes,
only
sir.
thing is that from learning point of view, if they spend more time, that will be good.
If for projects,
Or-
sir, can we send it for our
yeah,
students
yeah,
for six
project you
months,
can
sir?
send.
For 6 months, sir? Is it okay,
Yeah,
sir,
yeah,
for six
you
months?
can send, you can send. But we don't pay anything as per the
Okay,
guidelines.
no problem, sir. No
If they
problem.
can manage, we can. Yeah, that can be. Yeah, you can discuss with me. These are my numbers.
Sure,
Okay.
sir. Sure, sir. Yes,
Because I
sir.
have to speak to our because I cannot comment about robotics because I am not a robotics
Correct.
guy.
Yes, sir.
Okay, I
Yes.
have to discuss with our people, and if they can sponsor, they can sponsor. If they cannot sponsor, see, I'm
Even they are ready to work in the field of additive manufacturing also, sir. Our students.
if that is the case, then they can come to our lab, not a problem. But
Okay, sir. Yes, sir. Yes, sir.
yeah, just put me message. This is my WhatsApp and call 863 393 843.
Sure, sir.
Other one
Sure.
is only call. So
Okay, sir.
other one sometimes it is all signal based. It is a B. Okay.
Okay.
So
Okay, sir.
first one
Thank
will
you.
work. Yeah.
Thank you
Thank
very
you.
much, sir. Thank you
Thank
very
you.
much. Yes, sir.
Yeah.
Next question is Prashant Takmari. Okay, no, it's a compliment. Raviji, you got a compliment. Nice session.
Hello.
Yeah, Raviji, you got a compliment about the session. So people are liking your session. In the previous session also, there are a lot of
Hmm.
good points. Now, next person. Okay, that is regular. Kindly, please take care of the Manipan. Pandi, you can just check in the WhatsApp group in the admin, some 3 or 4. So you can check with Siddharam, one more admin is there. He is our full-time research scholar. He will help you with this. Please contact him, Pandi. And yeah, from Prashant Kakmari, one question is there. Yeah, so Prashant, can you unmute and ask the question?
Hello. Good evening, sir.
Yeah, please go ahead, proceed.
Hello. Am I audible, sir?
Yeah. You are audible.
Yes, sir. Yes, sir. Sir, I'm from KLS GIT only.
Okay. Yeah.
Myself, Prashant Kakmari.
Hmm.
Sir, I am from thermal background.
Hmm.
You were discussing about micro and nano machining type.
Hmm.
So, how about the thermal challenges you take care while machining with the small things and other things like micro and nano scales? That was my question.
Thermal challenges means?
Like sir, temperature controls and material properties, or while usage also, how it behaves with the change in temperatures and something.
See, for example, normally, as I said, no, for example, whether you are working on a conventional machining process, it's all depend on in conventional machining process, as I said. Okay,
Okay, sir.
mostly the temperature is primary function of cutting speed. If you take a conventional machining process,
Yes, sir.
so if you are going with low speeds and low depth of cut and low feed, you don't have much problems.
Okay, sir. Okay.
But whenever we are going with respect to high speed milling or high speed turning, normally we have high speed attachment, which I forgot to tell you in the micro machining center DT100i. We have a high speed attachment also, which goes around 60,000 RPM. Okay, so 60,000 RPM at the time you need to go for approximately a good variety of cutting fluids. Basically, you take, so there are two problems that you may encounter. Problem number one, you need to, if your temperature goes up, the
Yes, sir.
cutting tool thermal softening will takes place and tool will, there is a chance of catastrophic failure also. So to
Okay.
overcome that, you have two solutions. One, going for a better tool like a PCD tool or diamond tool or something. Option one. If you
Yes, sir.
have money, okay, that is all subjected to the cost.
Yes, sir.
Otherwise, you people can go with respect to the cutting fluids basically. Am I right? So normally for economically, people will go for cutting fluids.
Yes,
In
sir.
the cutting fluids also, what you do, there are multiple options that you have. One, whether you require high lubrication or high cooling. So since you are talking about temperature, so you need to strike the balance between lubrication as well as cooling, because your lubrication will reduce the friction between tool and cutting. I'm talking about micro milling actually. Okay.
Yes, sir.
So
Okay.
second, you should have a cooling effect. So you can mix 1 liter of cutting fluid with respect to 4 liters or 3 liters of water. Water is a very good coolant basically. So it also will give you sufficient. This is the solutions and how normally we can take care. However, in some cases, people will try to mix this. Along with this, they will send with a high pressure or MQL systems also they will use. So that what will happen? This will become a mist. Mist means like a,
Yes, sir. Understood.
I mean, say you know the mist. It's like a fog type. It's a gas. So it's a liquid that you are splitting into droplets and you are sending. The droplet size that you need to understand by we have our system. So that no, you are sending with high pressure. So it is a jet, which is the air jet, which has convective heat transfer coefficient of the cutting fluid. At the same time, it is pressurizing, so forced convection will come into picture, and you can extract more and more because the penetration in the seizure zone of machining will takes place more. Because of that, what will happen? It can penetrate more and it can extract because of the forced convection. So this is how normally we try to do in
Micro milling.
micro milling process when we are going with respect to high speed milling.
Okay, sir.
Yeah. Hope you got the gist.
Yes, sir. Yes, sir. Thank you, sir.
Satish Herikar's question in the chat box, like with respect to internship, I think he's talking about summer internship, wherein some minimum time was mentioned. So he's asking whether 16 weeks is okay. Can it be accommodated at your institute?
Yeah, I think fine. See,
Yes.
we don't have any problem, boss. The problem is we are a new institute, accommodation and other things. Yes. So see, if the students can take care because they have to stay in the PGs. So we have accommodation up to certain limit, beyond which if they can take care, we don't have. See, uh, we can provide them the lab space, we can provide them the machines, we can provide all the necessary things. Only thing is that sincerity, hard work, and perseverance that they should do. So that no, they they will get a good output of it. And this, anyhow, they are going to work with us as well as their mentor from their whole institute. So if they do better, they are going to benefit in terms of publications, and their host institute also benefit out of that, because we are very open minded. And however, the only request that is, if it is consumables are manageable from our side, we can manage. For example, if they want to do very costly experiments, then we have our own limitation. Hope you understood what I mean to say.
I think Satish Herikarji, yeah, it's clear.
Yeah. If they have any further question on this one, they can ask definitely.
Anyone who wants to unmute and ask, the restriction has been lifted. They can please ask. Okay. Now, few things like we had, you wanted to know about funding. Can you share your experience, Raviji, about applying for research funds, and like how, like you can share your experience. What are the
See, research funding, particularly what they want, anybody want, if they ask.
So, what are the like possible funding platforms here? What you know right now?
See, funding platforms, all the people know. See, you have DST, you have SCRB, which is called ANRF now, and you have DRDO, you have ISRO, you have MNRE, Ministry of Renewable Energy, you have DBT, Department of Biotechnology, you have what are the other things? ICMR is there, CSIR is there for bio and other related. So what are the, so you have almost all Indo-French, Indo-US, Indo-German. Many opportunities are there. Funding agencies, different funding agencies are there, and you can apply. Subjected to, my strong suggestion is you should have your own area of research within which you should able to find the application of it, rather than looking somebody's area. See, my thing is, for example, I am having my expertise in X area. So go deeply in that Excel to Excel basically, and find the applications in bio, find the applications in aero. Find, see every problem or everything. I'm talking about manufacturing basically, because okay, additive manufacturing or anything. For example, take additive manufacturing. Additive manufacturing has biomedical applications. Additive manufacturing has aerospace, automobile. You take anything you have. So if you are expertise in additive manufacturing, you just go into the deep and deep. Okay. Just you say that I will manufacture a component using a machine, you may not get funding. So the people look at the new science what you are bringing. So see, the funding people or any other people, there are two things. One, innovative science is there or not. Second, any product is coming out of or not. So these are the two things if you can keep in mind and write. So we are here to help our nation definitely. So if you can do a good novel science, the highly competitive paper will publish in a very good journal. So our value increases indirectly, our country will progress in new science and other things. Again, if you are producing an innovative product, definitely all funding. See, they don't. I don't think anybody see whether you are submitting from a private engineering college or whether you are submitting from any college. So novelty or innovativeness and non-obviousness, and these are all good things are there in your project proposal. I'm sure that you will get funding now. If not in one agency, you may get another. Okay, always it's not the night now. It has to come the day also. Okay, so you as a manufacturing people, you look at the product basically. What is the new product? So whether you can you see whether innovative product you develop or otherwise existing product can you your new science if you add can you bring down the product cost? For example, simple example like that when you have a key, no car key, just automatic locking system. So previously some people used to have the technology about 5,000. That is what the story. How far it is true or false, I also don't know. Just the story you listen as like a story only. Okay, so they said it is 5,000 or something the technology. Later it is developed by some other with a new science. Now currently the cost is 750. So it is a product the same. You can reduce, that is where the science plays a crucial role. Okay, and you are innovating a new product with less price. So it is a combination of striking balance between a science that you are developing at the same time the product. If you have these two, I'm sure that all the people can fund you definitely. So yeah.
Yeah, yeah, beautifully put up. That was the crux, like novelty, innovation, some part of utility,
Yeah,
product. Realization.
yeah, you can stop recording anyhow. This is non-technical thing. Yeah.
Yeah,
Yeah.
I think people were asking this, so they want to listen again. Revisit 2, 3 times.
No, there is nothing. See, whether I tell or any other people tell, it's the same thing only. See, at last we tell to our children, no, अच्छे से पढ़ो. That's all. You have to see. I told this from the whatever my experience. So we did, as you might have seen my presentation. So we have developed the product. So to come to that stage, as you can see that we started in 1996. The final product came in 2019 or 20. So this one, no, Rome is not built in a day. When I first time applied, I have not got any problem. So it is the experience that I say. We moved on. Okay. Oh, my first project we got. Then it is always a happy moment. Yeah. So lot of the things you learn, but first you start applying it. So without applying, you may not understand much. When you apply, you may be called by the committee. The committee may see you might have thought in one direction. There may be a committee expert. They are very intelligent people will be there. So they will ask you some other direction which you might have not thought. So that's how you learn. Whether you get it or not, it is immaterial. But there is an opportunity to learn. Okay, so then next time what you do, you just overcome that. See, it is life is all about minimizing our errors. For example, if your funding proposal has some error, which is pointed out by some committee member or some of the reviewer, so that is how you need to correct it and make minimum errors or error free or how to move. See, this is how you move. Whether you get a project or not project, at least you got the knowledge. That is what I when I started my career in 2012 as an assistant professor, when I proposed this, I also not got it, but I got questionnaires, I got the review comments, that this. It is like a paper only, no? You submit a paper, you get lot of review comments. You can, so this review comment makes our paper much better, much better. First review, second review, third review, like that. So first project you apply, review comments will come, maybe rejected. Second, again you apply with up. So updating the project proposal and other things. So like that, you have to move. Learning is a continuous process.
Yeah, Raviji, excellent session. I think many of us are impressed by your profile. At such a young age, so many achievements. That was the discussion happening in the coordinators room. So happy to have you on board for our FDP. So,
Thank you. Thank you. Yeah. So already 8:30. So I am disturbing all people dinner. Some of them maybe. Oh, okay. So good. And next time, whenever there is an opportunity, we can meet in person. Any programs are there? Please come to IIT Tirupati. We
yes,
are happy to host.
yes.
So
I'm Ajay's classmate. So he's hosting
oh,
a
exactly. Okay. So Ajay is with us. So Ajay is also have some program in September.
Yes, yes.
Friction-based processes. Professor Satyam Suhas from IAC Bangalore. We are conducting along with IIT Dharwad and IIT Patna and at IIT Tirupati. So it is an amalgamation of three IITs. So it will be a beautiful program. So that is a conference where you need to submit a paper. Here you need not to submit any paper. That's the only difference.
Yes.
So here experts will talk. So what is the latest trends from our group from Germany? So as I said, no, so our group in Germany will talk about what are the latest technologies, and we have people from CMTI Bangalore. Director CMTI Bangalore is coming to talk. Defense people are coming to talk on defense applications. What is up? And they are going to pose some of the challenges. I mean to say some of the problems, so that no, you can discuss with them and you can see one other thing. Other thing is these type of symposiums. We will welcome the defense people, aerospace people like ISRO, DRDO, and other people. They will come with the problem statements. When they project these problem statements like 20, 30, like respond basket is there. Okay, they pose these problems. If you can solve with your research, they will give funding. When they are here, you can discuss with them, sir, this is what I'm thinking about this particular problem. Can you just get the feedback? So you ask again question. So some of the information they will give about that particular problem. For example, if you want to assume that if they want to print a 3D printing of a wind tunnel model. So just they say, sir, what is wind tunnel model? How the wind tunnel model? So the design will be given by you or whether we have to design. What is the material that you are expecting? What is that? What is this? So once you get all the information, so you can pros and you can also get in contact with them and you can submit a proposal, get it vetted by them. Then you submit it. There will be a heavy chance that you get it because in India requires a lot of technologies. That is what I can understand. Alone you or I cannot do. It should be a combination. Okay, you have to have assume that as I said, no, this particular project I did along with IIT Delhi because I don't know electronics. Definitely, I have my own, but I know how to make the system, but I know what I want in electronics. I can explain them that this all I want in electronics or mechanical movements I want, so that they will design the electronics. So long journeys, if you want to do, collaborate and do. Okay, with your colleagues from electronics department or computer science department. Okay, so and most important thing that I always tell is research is one part of your life, but being a good human is is the most important one. If you are a good human, your collaborators will be good, and your thought process will be good, and your thinking in the right research in the right direction will be there. Okay, so think about that. When I am doing any research, is it worth doing? Put your hand on your heart and think whether whatever the research that I am going to do, is it going to help the poorest to the poorest of this country? If the answer is yes, I am damn sure that you will get the funding. I am damn sure that you will get the funding because your research is going to help the poorest to poorest. And second thing, you first time whenever you are applying the funding, you apply as minimum as possible so that there will be a heavy chance that you will get it. Okay, because when you are applying for first time, if you ask for 2 crores or 3 crores or something, or 50 lakhs or 60 lakhs or something, so the committee on other side, that is what my professor told me. So you should have a proven track record to ask more money. If they don't have, so do you think you will give 10,000 rupees to your LKG son or daughter? You don't give. You give 5 rupees only. Na? Think. What did you do? They don't know how to spend it. Or it's not that they don't know. My example may be wrong, but only thing is that first time whenever you are putting a project, first and foremost is whether this has a great impact on changing the lives of a poor person of this country. You will get it definitely. Second point to notice, you ask what is required, whether it is 10 lakhs, whether it is 20 lakhs, you ask to the point. This is manpower, this is that, this. So I am sure that you will definitely get it. Thank you.
Very, very pertinent and very good inputs. Definitely, all our participants benefited from this. So, thanks a lot, Mamilla ji. You too must be tired. Continuous 2 sessions today. Uh, 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 from the organizing team, we thank you from the bottom of our heart for your valuable time, sparing time with us, and sharing your knowledge. Yes, all of us. Thank
So,
you, Ravi.
so thank you, and hopefully some of you may be attending our program. And the second thing, if you have any support is required, I already showcased my number. I don't know whether you have noted or not. So if you have anything, you just put me WhatsApp. Normally, working hours we may not lift the call because being a head of the department or being in meetings or being in class, our primary requirement is research and teaching. So once we go back to the home, we see the missed calls and we'll come back to you. Okay, don't think that IIT प्रोफेसर है मेरा कॉल लिफ्ट नहीं किया है कि आप लोग ये भी सोचिए कि हमारा परिस्थिति किस परिस्थिति में हम लोग भी हैं. So you just put a message that I am so and so. What is your free time to talk to you or something? So we are more than happy. And I don't know. There is one conference in Dubai. So my phone may be switched off from 15th to 23rd or 22nd. I will be out of country. Okay. So thank you and hope to see you in my conference. If not, if you have any conferences, do let us know if the time permits or everything permits. So we will be definitely helping you. We are here to help you. Okay. As I said, no, if my research is going to help anybody, if I can inspire one person out of this group, I will be more than happy. That is what I always told. Recently, somebody, I have an experience. So I don't know. And suddenly I got one sweet packet and one flower bouquet. I'm telling about 2019 or 20. Yeah. So I got it. So there is a message in it because nowadays I'm not saying that you have to send me or something. No, I'm just telling about my happiness. I'm saying. So it is written one number after that message. I'm very grateful to you, your advices and other things so on. So then I don't know who is that person. So since they have given number, I called. He is from one guy. 55 years old or 53 years old person. He met me in 2007 when I was a student, or 2009 when I was a student at IIT Kanpur. And I told him some inspiring words during dinner time. Okay, that helped him trying and trying. He has an ambition to do PhD in IITs only, and he tried from 2009 or something. He achieved that in 2019 or 18 something. So he sent me a bouquet, sir. After long struggles, now I got a PhD in IIT. Okay, at the age of 50 or some 50 or 52 or 53. So I am, because of your inspiration, I fundamentally the problem is that sometimes we don't remember those things, but as I said, no, those people remember. That is a good thing. So for example, if I take in a reverse scenario, when I started my PhD, in my jab I have only 400 rupees. My registration fees is about, yeah, 17,000. So yeah, so the thing is I have below poverty line person. So there was one faculty called Anupam Agrawal, who is now professor in. So when sentiments, no, so I borrowed from 20,000 from him. I paid 17,000. I procure a second-hand cycle for 900 rupees. I spend another 1,000 or something for the mess charges. These are the difficulties. When I told him this thing, oh Ravishankar, when I met him after 10 years or something, I told this. Oh, I don't remember all those things. This what? No, those people who experiences, they people remember. See, in the first case, I don't remember. In second case, the giver don't remember. So life is like that. Okay. So life is full of struggles. So you have to overcome it. That's the only way to come out. Do hard work and excel in life. Yeah.
Thank you, Raviji. Now we have loaded the feedback form for today's both the session chat box. Participants are requested to give the feedback. And thanks for a wonderful talk for both the parts, session one and session two, Raviji.
Yeah. Thank you.
We look forward for inviting you in future too on different occasions, different events.
Yeah. Yeah. Sure. If I can help, definitely. Thank you.
Thanks. Thanks a lot.
Thank you.
See you.
Yeah.
The feedback link is put. All participants can give the feedback. Stop recording.